The year is 1900. Paris is abuzz with the excitement of a new century. The Eiffel Tower, a symbol of progress, has just celebrated its 12th anniversary. At the Sorbonne, a young mathematician named Louis Bachelier is defending his doctoral thesis.
Little did he know, he was about to ignite a revolution in finance. Bachelier's thesis was audacious. He dared to suggest that the seemingly chaotic movements of stock prices could be understood through the lens of mathematics. This was a radical idea at the time. Most people viewed the stock market as a gambler's paradise, driven by speculation and emotion.
Bachelier, however, saw something different. He saw patterns in the randomness. He believed that the unpredictable dance of stock prices could be tamed, at least partially, by the power of probability. His thesis, The Theory of Speculation, laid the groundwork for what we now call mathematical finance.
Before Bachelier, finance was not considered a suitable subject for serious mathematical study. It was the domain of intuition, gut feelings, and perhaps a touch of luck. Bachelier's genius lay in recognizing that even in the unpredictable world of the stock market, there were underlying principles that could be expressed mathematically. He argued that stock prices follow a random walk. Imagine a person walking aimlessly, their steps determined by the flip of a coin. One step forward for heads, one step back for tails. The path is unpredictable, yet there's an underlying mathematical framework governing the probabilities of each step. This idea was met with skepticism by the academic establishment. Mathematics, they argued, was the language of physics and engineering, not the seemingly irrational world of financial markets. Bachelier's thesis received a lukewarm reception. It would be decades before his work was recognized for its true significance. Despite the initial skepticism, Bachelier's thesis contained groundbreaking insights that would later transform the world of finance. His work revealed three fundamental truths about stock price fluctuations. First, Bachelier recognized that price changes are random. Past price movements provide no reliable information about future price movements. This challenged the prevalent belief that one could predict the market by analyzing historical data. Second, Bachelier showed that price changes are independent of each other. The price of a stock today has no bearing on whether it will go up or down tomorrow. Each price change is like a flip of a coin, a fresh start unaffected by previous outcomes. Third, Bachelier demonstrated that the probability of a price change of a given magnitude decreases as the magnitude of the change increases. In simpler terms, small price fluctuations are more common than large ones. This principle has profound implications for understanding risk and volatility in financial markets. Bachelier's work introduced the concept of the normal distribution to finance. Also known as the bell curve, the normal distribution describes a wide range of natural phenomena, from the heights of people to the distribution of errors in measurements. Bachelier used the normal distribution to model stock price fluctuations. While it was a groundbreaking step, it wasn't a perfect fit. The normal distribution assumes that extreme events like market crashes are exceedingly rare. However, history tells us that financial markets are prone to occasional wild swings, much larger than predicted by the normal distribution. This mismatch between theory and reality highlights a crucial limitation of Bachelier's model. While the normal distribution provides a reasonable approximation for day-to-day market fluctuations, it fails to capture the full spectrum of market behavior, particularly the fat tails of the distribution where extreme events reside. Section 5, Levy flights and the wild swings of the market. Enter the fascinating world of Levy flights.
Named after me, Paul Levy, these patterns describe a different kind of random walk, one that better reflects the occasional wild swings observed in financial markets.
Imagine an albatross soaring over the ocean. It flies for long stretches in a straight line, then suddenly makes a sharp turn, covering a large distance in a short amount of time. These abrupt changes in direction are characteristic of Levy flights.
Unlike the normal distribution, which assumes all steps are roughly the same size, Levy flights incorporate the possibility of occasional large jumps. This makes them a more realistic model for certain financial phenomena, such as stock market crashes or the sudden rise and fall of cryptocurrencies. Section 6. From bird flight to stock prices, the power of analogy. The beauty of mathematics lies in its ability to connect seemingly disparate phenomena.
Who would have thought that the flight patterns of albatrosses could shed light on the behavior of financial markets?
By drawing analogies between the natural world and the abstract realm of finance, we gain a deeper understanding of both.
The albatross, with its Levy flights, reminds us that extreme events, though rare, are an inherent part of complex systems.
This realization has profound implications for risk management. Traditional models based on the normal distribution may underestimate the likelihood of extreme events, leaving investors vulnerable to sudden market shocks.
By embracing the insights of Levy flights, we can develop more robust strategies to navigate the inherent uncertainty of financial markets.
Section 7. Bachelier's impact ignored, then rediscovered. Bachelier's work, though groundbreaking, was largely ignored during his lifetime. He was ahead of his time. The mathematical tools needed to fully appreciate and extend his ideas were not yet available. Furthermore, the world of finance was not ready to embrace the power of mathematics. It wasn't until the 1960s, decades after Bachelier's death, that his work was rediscovered by economists like Paul Samuelson. The development of computers and new mathematical techniques allowed researchers to build upon Bachelier's foundation and develop sophisticated models for pricing options and other financial derivatives. The rediscovery of Bachelier's work marked a turning point in finance. It paved the way for the development of quantitative finance, a field that uses mathematical models and statistical analysis to understand and manage financial risk. Today, Bachelier is hailed as the father of mathematical finance. Section 8. Modern Finance, built on Bachelier's foundation. The legacy of Louis Bachelier is all around us in the world of finance. His insights laid the groundwork for many of the tools and techniques used by investors, traders, and risk managers today. Options pricing models, portfolio optimization strategies, and risk management systems all owe a debt to Bachelier's pioneering work. His ideas underpin the complex algorithms that drive high-frequency trading and the sophisticated risk models used by banks and hedge funds. Bachelier's influence extends beyond the world of finance. His work has had a profound impact on fields as diverse as physics, biology, and ecology. The concept of the random walk, for example, is used to model everything from the movement of particles in a gas to the spread of diseases. Section 9. Bachelier's enduring lesson. Embrace uncertainty. Perhaps the most important lesson we can learn from Bachelier is the importance of embracing uncertainty. He showed us that even in seemingly chaotic systems, there are underlying patterns that can be understood and even exploited. The world of finance, like the universe itself, is full of unknowns. By acknowledging this inherent uncertainty and developing models that account for it, we can make more informed decisions and navigate the complexities of financial markets with greater confidence. Bachelier's work teaches us that the pursuit of knowledge is an ongoing journey. His ideas, once dismissed as too radical, now form the bedrock of modern finance. His story is a testament to the power of curiosity and the enduring impact of groundbreaking ideas. Section 10. Bachelier, the father of mathematical finance. Louis Bachelier's journey from obscurity to recognition is a testament to the power of ideas. His story reminds us that innovation often comes from unexpected places, and that groundbreaking ideas may take time to find their rightful place in the world. Bachelier's legacy is not just in the mathematical models he created, but in the way he changed our understanding of financial markets. He replaced intuition with analysis, guesswork with probability, and ushered in an era where mathematics became an indispensable tool for understanding the complexities of finance. As we navigate the ever-evolving landscape of financial markets, it's worth remembering the pioneering work of Louis Bachelier, the father of mathematical finance, who dared to see order in chaos and paved the way for a new era of financial understanding.